Welcome back, dear friends. I was getting carried away. It's after lunch and I was happily, merrily getting on with this, and suddenly remembered I hadn't actually uttered a word. So let's just recap what we're doing. Remember the last video, I was getting all the wires, all the visible wires, hidden away with a multitude of rubber pipes and copper pipes and all sorts. Let me show you, in fact. That's right, it's all coming dripping back. I just put that bit on, which was nice. That was to hide the wires from the limit switches for the carriages. And then, look, this was so enjoyable to do. Again, no plans, you just start and you just figure out as you go along. So I've got 4 lots of copper pipe coming out, one for each of the stepper motors, in through which all their wires go, so that's nice. It just looks so nice with all the angles. I can't really get to it, but you get the idea. And I made the typical mistake. I started off by putting this right up in front in line of one of the tuning key things, so I had to move it because obviously I want to have 2 motors connected to them. But that looks really nice, the little thing, dinky little gem in the end of that to support the pipe. Oh look, glinty, what fun. So I got that done. And then I dismantled this, because there comes a time, etc, etc, when you've got to move everything, install it in its new home. So I've got the mega fix down. I cut out lots and lots of titchy little spacers from 3mm acrylic with a hole just the right size. The smallest screws I've got to fix things like the Arduino down are these number 6 1/2" brass ones, it doesn't matter. But they just fit perfectly in the oval. So I've got spacers underneath, because otherwise, with all the bits sticking up, for example, on these, here's one of the interfaces for the I'm using to control the plucker motors, you've got all the solder joints underneath, so if you just screwed them down, that wouldn't be very good at all. It would flex and strain and break tracks and things. So the spacers are there, I've got that screwed down, and one of the top tips that I've found when using an Arduino in a machine with a wooden cabinet around it, get one of these USB-B type, I think it is, take the shroud off so you're just left with a much smaller version of the plug. And I found, using one of these rivets that you can buy for clothing, textiles and things, it fits. And if you line it up carefully and fix the Arduino down in the right place, get out of the way, it lines up perfectly with the USB socket. And that's brilliant, because it means that once you've got it all wired up and enclosed and everything else, and then you want to program it or fiddle and fart around with the sketch inside, you can leave it in situ and just plug that in. How fabulous! Hey, thank you very much. So that's done. Then I came to fixing down these two and realised, of course, they do get hot. Oh, and by the way, I added more copious notes because I really don't want to forget what goes where. So hopefully I've got all the information there, so I can recreate what I had before. So ventilation, let's talk ventilation. And because it's a really stupid thing not to have done, but like I say, I've not planned any of this, I used a hole saw like that. The great thing about these is that they don't put too much force on the wood. If I was using a flat bit or something like that, it would be a disaster, because it would grab it, snatch it and wreck it. So using one like that was perfect. Slowly saws through, so that's to let air in. And then what I've just done, and this is the first time I've tried this, I've made an escutcheon, or whatever it's called, out of the way, to go around the outside. I'm going to stain it and fix it on, but I'm going to have some mesh, some of this lovely fine stainless steel mesh, a disc of it to fit inside here. And I thought I would focus, engrave it. So I engraved it at lower power, and it's just got a lovely little rebate there. Perfect. Now I'm going to cut this out, and the best way to cut that out is to put some masking tape on it, and then to use a pair of snips just to cut round it, and hopefully that'll then fit in there. 48mm diameter, using my lovely old, what make was it? Schreiber, is it? Steedler, that's right, Steedler. Set of compasses that I've had since I was at college. Absolutely fantastic, especially with that adapter. It's such a joy. I appreciate it every time I use these, that I don't have to rely on some little bit of lead that's stuck out, that's snapped off or something. I can actually put a proper biro or whatever inside. Lovely. Right, I'll get on and get back to you. Oh, and by the way, thank you so much for the viewers and subscribers who got back to me and said they really do like me explaining the process behind things rather than just an end product. I'm really pleased. I love it because it really does seem like I've got company when I'm working on this sort of thing in the workshop, because I'm always thinking about next steps and how to explain things. It's really nice, so thanks very much, greatly appreciated. And if you like this sort of thing, do remember to click subscribe, the bell button, and something else, like, that's right. Thanks very much. Let's get on with it. And today, and last night's viewing pleasure, is Sunshine. Brilliant film by Danny Boyle. Really good cast. Cillian Murphy as well, who's always fantastic in it. Very good. And what I've done, I've watched the original, the proper version. Then I've watched it through listening to Danny Boyle's commentary, which was really good. Now I'm watching it through listening to Professor Brian Cox's commentary. Some people may call it sad, but it's nice because I don't have to look at the film because I've seen it, and I'm listening to all the scientific reality that goes into it this time. Lovely. By the way, these are amazing things. I was given these for my Christmas present when I was about 12 by my grandparents. That's a very long time ago, and they still work perfectly. The edges are absolutely perfect. Those were the days when they actually knew how to make metal, not this rubbish you get from New Zealand as well. Tunnon in New Zealand, don't know whether they're still around. But for the best part of 50 years, perhaps a bit less, they have continued cutting things beautifully. How lovely. It's so nice when you have a tool that means a lot to you emotionally, and just how fabulously it works. Just a little update. I've got all the other interface boards screwed down. I've got a piece of Vera board just plain, so I can use it to connect all the common grounds and plus 5 volts and things. And I'm just sorting out how to mount these two. These are the interfaces that run the small stepper motors that are going to do the tuning. And I want to use the normal window that I used on several other machines, because as they operate, especially if they're going slowly, which these stepper motors will be, you can see each of the circuits switching on in order, so you can see a row of little red LEDs flickering along, which gives a lovely effect. It's really handy as well because it shows you if something goes wrong, you can see that at least the electrometry is getting to this bit if they're lighting up, or not if they're not. It's a shame to have all these lovely lights and things hidden away inside when no one sees them. So I've just cut out a block of wood because they need to be a certain distance, not too far away. So I'm just going to, it's going to be like that actually, and I can screw them with the LEDs facing in towards each other, and then the outer side of the window, oops, I use another one of these wonderful textile fabric rivets meant for jeans and things. I can imagine what part of a pair of jeans. Anyway, to build these little things in, and that's going to be able to sit on the front panel, and you'll see a nice little load of flickering LEDs. The other lovely thing is not planning where everything's going to go on this front panel. I have no idea, which is far more like Victorian engineering, because their positions of controls and everything were simply dictated by mechanical needs, or how short a run of pipe they could get to connect a gauge to. So things never were arranged ergonomically, so to speak. They're all over the place, and that's what this will end up like. if I've realised a moment ago that it's probably not even going to be possible to see the ukulele very soon because of all the extra stuff I'm putting on. It's absolutely ridiculous, but it looks nice. Anyway, I'll get on with that, and then I'll get back to you. Now I've exhausted all of the extras and features on Sunshine. Can you see what film it is I'm watching now? An absolute classic. Zoink. Alien. It is such an incredible film. I was in the 6th form secondary school when it came out, and yet it still isn't dated. It's still brilliant. When you think about a lot of the other science fiction films of the time, the era, sort of early 80s, late 70s, they look so dated with the fashion and everything else. It is absolutely typical, isn't it? It's absolutely brilliant. Hi, wait for the camera. Right, I'll get on with it. This makes me so happy. It really does. I'm in my element. So if you look at that, I've got me soldering here, soldering on there, joining up these stepper motor wires back onto their plugs. I've got, trying to focus it, I've got alien up there. I've got the dog waiting to go for a walk, but my wife is going to take, it's her day off and she's going to take the dog out. So I can just sit here and just get on with this loveliness. Oh, it's such a joy. Right, I've got all of those fixed back on so they can be connected up to this interface board. Now, the lovely job, one of my favourite jobs, is to connect all the plus 5 volts and all the 0 volts, the grounds, together and solder them onto the little bit of error board. Very satisfying. Just looking around and collecting all the grounds, especially because everything has got a ground wire. So I will now get that done. I love this bit because I saw it and I thought, I know what that is. It's an iris off a follow spot. Look, oh, it's not going to focus if I do that. Isn't that beautiful? They're the most incredible things. They're so beautifully made. But that goes in the focal point, if you like, in a follow spot, and then, at least an old-fashioned one, then you could control the size of the beam. It's just, look at all those discs. I've covered it in graphite to make it slip because it was a little bit rusty originally. Isn't that amazing? I've had it for years. I can't bear to get rid of it or use it in anything because it's just such a beautiful thing. But that's what they used on Alien. Well, that was fun. So enjoyable. And as you can see, I've got all the plus 5 volts, plus 12 volts, 0 volts all connected up together there, and then all the other wires, hopefully, in the right place connected, and the stepper motor supplies coming through their copper pipes along, plugging into that board, hopefully the right way around, etc, etc. The only way of telling is to switch it on and see what happens. Now, yes, what I was going to say was, the Arduino and the circuitry on a lot of these chips and things, and those interfaces and those stepper motors all run off 5 volts. And on all the other machines that I've built, all I need is a 5 volt regulated power supply to run everything, which is lovely. But with this ukulele playing machine, the stepper motors, I've discovered through trial and error, run best at 12 volts. But I realised recently there is a 7805 voltage regulator on each one. I suddenly thought, why not use the 5 volt outputs from these, because I checked it with a multimeter and they do produce 5 volt outputs, to run all the 5 volt stuff. So I'm going to try that. I'm going to give that a go. A little bit hesitant because it could just go up in and release the blue smoke and all that, but I'll give it a go and I'll get back to you. Oh, and there's that lovely little vent. I'm very pleased with how that worked out. That looks lovely and lets lots of lovely cooling air past all the hot pieces. Let's talk cooling, dear friends. As I may have mentioned, I came up with the idea, absolutely ridiculous, that I could blow air through the tops of each of the plucking motors, because I'm running them off, as I say, 12 volts rather than 3 volts. Short pulse, so it probably doesn't need it. But then I thought, well, it would be lovely, it would look absolutely fantastic if whilst this machine is playing, there's also some sort of pump system, mechanical pump system, working to blow air through these things. And obviously, I don't want to cheat and just have some stuff moving. Everything on these machines does fulfill a purpose. So, whilst walking the dog the other day, this is when I come up with most of my useful, I hesitate to suggest, but ridiculous possibly, ideas, I suddenly thought, well, universal joints there, I think that's what got me thinking, because they're used on cars, obviously, to get the engine connecting and turning the wheels, and because they're delicate, lovely things, they're protected with gaiters, which are the flexible rubber squeegee sleeves that go over them to keep everything nice and clean inside. That's where I started. Then I thought, ooh, can you imagine a big concertina gaiter up here that's fixed at the bottom with some sort of valve, copper pipe to take the pressurised air into the air chamber here, and then some sort of complicated mechanical. Luckily we've got this whole edge along here, plenty of room, some sort of mechanical things, possibly with the bead chain, pulling up and down on a crank to work this with a nice valve system at the bottom that could even be transparent. You can see little flappers moving backwards and forwards. Oh, I mustn't go out so much with the dog, it's absolutely ridiculous. So I thought, where can I get one of those? Well, why not start with Amazon, just out of interest? So I found this. Amazing. It's 50mm, that's 2 inches diameter, and 130mm, 13 centimetres long, which is, well, say 6 inches, but can stretch up to a foot, 12 inches or 300 and something millimetres. It's absolutely ideal. These are 30mm diameter, so that's great. And it looks like it's quite thin, fine rubber. It's not one of the big ones with huge radiuses on it, which would take a lot of force. I think this will be perfect. I'm so excited. I had to share this with you. I know it was 20 quid, but needs must. If I'd gone to a car place, I probably would have paid well over the odds for that. I can't wait, the thought of that, because that's black as well, so it goes with the other rubber black things that are making up this machine. But just imagine it going up and down, blowing air, for real. Anyway, stop it! The moment of truth. The wire. Unsheathed so it fits through the hole, the plug. Through to there. Here's the doodah, the sketch that's uploading. Now the good thing is so far there's no blue smoke appeared, even though I'm running everything via the USB 5V supply. So that's great. The lights haven't come on those. Lights, no lights on those. That's a good sign. That's nice, that makes me happy. Put the camera on the tripod because you can sense the trepidation. I'm going to switch on the 12V supply having pressed the reset button. So let's see, press that. Oh, red lights come on there. So far so good, because I really didn't know whether it was all just going to have puffs of smoke. I just suddenly smelt burning and realised that it was my soldering I was standing over. Oh. Good start. That didn't crash. Ooh. No, I haven't tuned it for ages, so it's... But I'm so pleased. So pleased. That means that I have managed to recreate everything from before and get it all wired up nicely, enclosed in copper, and the circuit does work properly. Oh, I'm very pleased with that. Excellent. Right, so the next thing to try, because obviously if I unplug this, shall I? Yes, I can. Still no smoke, that's good. I've unplugged that, which means that everything has lost its 5V supply, so the Mega isn't telling anything to do anything. So that's great, but look, you can see, hang on a minute, you can see the lights on these two. There's a light, which means they're still being filled with 12V, so that is producing 5V, which means I should be able to run the 5V from that to control all the 5V stuff, and then not need to take any voltage, or indeed have a USB plug plugged in at all. I will now try that for your delectation. Thank you. Look, no USB supply or computer. I've connected the output from that one actually to the 5V bus. That's fantastic. So I was thinking I was going to have a 7805 voltage regulator separate to this, but I don't have to, and I'm only using one of them because there's no point. They've got thermal protection and overload current protection, so theoretically things can't go horribly wrong, but right, so that's great. Now the next job is to work out what to do with these. In fact, I think I better take Ziggy. Do you want to go for a walk? I think it's time for Ziggy's walk. Come on then, drag me away from the ukulele machine. Go and point at some squirrels in the park, yes? Yes. Oh. As I was saying, before I was so rudely interrupted by the dog, these are the wires that go off through the pipes to the LEDs. If you remember, I made some lovely little flickering LED, well, they don't flicker, but LEDs with a gem on the top to indicate when each of the motors was plucking. Someone suggested that would be really nice to have some sort of indicator. I think that's a brilliant idea. But how to run them? Because the motors run from the H-bridge drivers. Let me explain. Here's a drawing I prepared earlier. This is the equivalent of an H-bridge driver. So we've got 12 volts coming in, plus 12 volts, 0 volts at the bottom, focus. Then we've got 4 switches. In effect, they're electronic switches controlled by logic, so you can't, for example, switch both of them on and short circuit that, because that would be bad, or equally switch both of them on and short circuit it. Can't do that. What you can do though is you could switch that one on and that one on. That means the electricity will flow through the motor in that direction and the motor will go one way round. Then you can switch it off, and then if you shut that one and that one, the electricity flows the other way and the motor turns in the other direction. Now the thing about LEDs is that they are light emitting diodes, and diodes only let electricity through in one direction, so it's not going to work. If I wired one across here, it would only work for every other pulse, which would be a pain. So I started thinking, well, we could use some other logic gates, we could do this, that and the other. I don't want to use the Mega. I could get it in the sketch and use 4 more outputs to run the LEDs, but there's a couple of reasons why I don't want to do that. One is that the outputs of the Arduino Mega only allow you to run, some people say 40 milliamps per output, others say 20 milliamps per output. An LED needs about 15 milliamps, say. But there are limits to the overall number that you can have, and anyway, I just don't like running too much current out of the Arduino. All the outputs here all go to some sort of interface device which has electronic switches that take care of all the power switching. So that's one reason. The other reason is I don't want to use up any more of these outputs, because as you know, if you've watched previous videos, I've got 54 roughly on this Arduino Mega, and I get through them at a rate of knots. I've still got another 2 of these interface boards for the other 2 motors, the tuning motors on the other side. So that's going to be another 8 outputs, etc, etc. Then, walking the dog, I suddenly thought, full bridge rectifiers, because these outputs, these interfaces can handle 5 amps, that's tons at 12 volts. And by using, hold on a minute, a full bridge rectifier, which looks like this, it's got 4 diodes in it, and so you've got 12 volts AC, which means it's swapping backwards and forwards lots of times. That you have these diodes so that if this is positive, if this is hot, say plus 12, it can flow down there, and at the same time that would be 0 volts, so that can sort of get electricity back through here down to there, and when it swaps over it does the opposite, but you get plus 12 and 0 volts there, which will run an LED. And as I say, the current is no issue, and I can easily put a resistor to limit the current through each LED. But then that means I've got 12 volts, positive and ground, which is brilliant. So I'm going to give that a go. Now, it's a very short pulse to these motors, so, you know, because I obviously didn't want to burn them out. So I don't know whether there's going to be enough time for you to actually see each LED illuminated, but that's what I'm going to try. And to work out the value of the resistor I need to limit the current, because if you just connect up an LED to 12 volts, it's going to burn out instantly. There's a very fine piece of wire inside, and you have to limit the current usually to about 1.2 volts at about 15 to 20 milliamps. So I've used the wonderful Ohm's law, V over IR, to come up with a value of 733.3333 recurring ohms. But I'm going to use 1K because that's near enough, and it'll give me an idea of whether it's going to work or not. Here we are. There's the bridge rectifier. There's the 1K resistor. I've just connected it to the output. I've just taken out the motor wires, so I've connected to that one. So I'm going to switch it on and see what happens. Right. Well, that's brilliant, actually. I don't need any capacitors or anything else. That's quite clear. So, oh, that's fantastic. Well, I've ended up replacing it with a 2K2 2200 ohm resistor, which is far higher than necessary, but because I'm not illuminating anything with it, that's much nicer now. You can sort of see the nice flower effect of that gem, and it's not glaringly bright, so I'm happy with that. Now to get on with these bridge rectifiers. Another day. Good heavens to Betsy, a tidy extension. Look, there's carpet. That's amazing. There's the carpet of invisibility. What's he done with all the stuff, I hear you cry? There it is. It's all piled up. What's lovely is my children's birthday party this afternoon. I don't think you can call it a party anymore. It's a, I don't know, whatever. But in the past, I used to move all the machines out, everything. And there was just enough room in this room for a lovely bouncy castle, which we've still got, and the kids used to do that. But now, you know, 2 years off with the COVID banning parties and things, and they're 14 and they're old now and they've got past all that, so they want a disco inferno. Luckily we're all set up for that, because as I've mentioned in the past, before this was a workshop, while I was still teaching, I got some of these because we used to end up having so many parties, and because this is very soundproof, and it's lovely too. They project huge rainbows of light that rotate. It's lovely. And there's even, well, there's the old mirror ball up there, and there's the little smoke machine. They used to have a bigger one, but it wasn't necessary really. And some more of those beautiful lights with mirrors. So we're all set up ready. I don't think they've thought it through really, because I don't think they're aware that at that age, in fact lots of ages after that, discos involve standing around feeling incredibly embarrassed, not wanting to do anything, let alone actually strut your stuff on the dance floor. It's going to be very interesting to see what's going to happen. But we've got the dear old pinball machine, fabulous, so that'll give them something to do, and the 3D printer if they want to 3D print something. Anywho, and the reason that there was a large cake sitting on top of the box or pile of net thrubwells is because every year they suggest, in the past at least, a birthday cake they'd like, and then we make them and the dog tries to eat them, and this year she even managed to get in here and get a big bite out of one of the sponges, but was caught just in the nick of time. In the past the cakes have ranged from, at least with Arthur, things like a mosquito biting someone and an autopsy and Gollum. There was the clown from It, and each year, and oh, the worst one was a Dalek. I mean, it's one thing to make an organic shape by carving sponge cake and then covering it with icing and things like that. To try and get a geometric shape, especially one as complicated as a Dalek, was so difficult. This is why I normally have such a small table. I've moved it, as I say, because this is going to become the Disco Inferno. Within a couple of hours, I've already managed to fill up a table twice the width. Hence the fact I normally use a small table. Now I've got these bridge rectifiers done. Look! Found some variable, obviously, a little bit of OCD. They all had to be exactly the same size, even though no one is ever going to see them. So each one takes the input for the motor and just passes straight through and off to the motor, and then it has the 4 diodes to sort out and organise a positive, which then goes through a resistor to the LED, and then the resistor comes back to the ground, 0 volts. Let's give it a go and see what happens. It's so lovely now, because all I have to do to start it playing, now I've sorted out the power supply, is just to do that. I'll edit this bit out to save you having to watch that. Are you ready? Ooh! I'm very, very pleased with that. I really am. I'm thrilled that they work perfectly. And there's a long enough pulse just to also work the LEDs. Fabulous. Next job, dear friends. Auto tuning. I can't wait, because obviously I've got the motors sorted out and the interfaces and connected up to 8 spare outputs on the Arduino, and I've got the input from that little microphone. I can't wait. Watch this space. One final question. I'm not sure, I'm walking the dog too much and coming up with too many ideas. My original idea was to put the tuning microphone and this little print circuit board, which I've currently lost, inside the actual body of the ukulele, and then have the wires coming out through some little brass pipe or something. And then, this very morrow, whilst walking the dog, I suddenly thought, hold on a minute, rather than invading the sanctity of the ukulele, I could have a horn over the top somehow, and a pipe coming across and down into the front of this, and have the sound, the monitoring microphone board in here, but with a lovely some sort of brass, copper something, with a little horn to amplify the sound sitting over there. Can you tell me which one you prefer in the comments, please? Because obviously it's difficult to see the ukulele as it is, and adding another thing above it and over it, well, I don't know, it might look too cluttered, and the way of having it mounted sitting inside the ukulele is far more discreet. So is it discreet or is it bleeding obvious? Let me know in the comments. Right. Thanks very much for watching. Hope to see you next time. Remember to click like and subscribe on the bell button if you like this sort of thing. Can't wait to see you next time. I've got all sorts of ideas about this auto-tuning thing, and I can't wait to try it. So exciting. Thanks again. I'll let the ukulele machine play me out.